Okay, so you have still a few minutes to fill the survey, and now we have one more an amazing speaker, Timantha. Timantha, you are with us now.
Hello, Yazaro. I'm right here.
Yeah, good to hear. How are you doing today?
Doing good. So I just came down to Toronto for my higher studies. So I'm presenting this session from right here. So yeah.
Sure. I'm very excited about your session. So again, the stage is all yours. I'm very excited about your ADF, the Azure Data Factory no-code solution. You can
Right.
start the session. Thank you.
Thank you, Arrow. So I'll share my screen right now. Okay. So hope you guys can see my screen right now.
Yes, we can see it.
Nice.
Yeah,
Okay.
thank you.
So you're right. Okay. So good morning, good afternoon, and good evening to everyone who had joined us from around the world. My session is about no-code data preparation in a modern data warehouse with Azure Data Factory. This session is based on the Power Query feature in Azure Data Factory, which is still in public preview. Have been interested about the feature ever since it was released in the year 2019. In this session, what I'll be doing is I'll be sharing my point of view on where should Power Query in Azure Data Factory be used in a modern data warehouse solution. Right, so let's get started. For those who don't know me, I'm Timantha Bidanakamge. I love working with Microsoft Data Platform technologies such as Microsoft Power BI, Azure Analysis Services, and Azure Data Factory. The most important thing out of all the details that you see in the screen right now is my Twitter handle at TimanthaV. So please follow me on Twitter at TimanthaV. Moving into the agenda for today, firstly, I will take you through the modern data warehouse and its architecture. Later on, we'll look at the data preparation in a modern data warehouse. And finally, I'll be wrapping up this session by showing you guys how to engage in no-code data preparation in a modern data warehouse. Firstly, it is important for us to know what is a modern data warehouse. A modern data warehouse is a data platform that is specifically catering for analytical purposes. So you can bring together all types of data, including structured, semi-structured, and unstructured data into a modern data warehouse. And when it comes to scalability and flexibility, there is a higher level of scalability and flexibility in a modern data warehouse solution. Scalability is coming from the Azure components, scalability of the Azure components used in the modern data warehouse solution, while the flexibility is coming from the data lake concept that's followed in a modern data warehouse solution. Right. So what you see in the screen right now is a modern data warehouse reference architecture. So as you can see the key components of a modern data warehouse here, which are ingest, show, prep and train, model and serve. Prep and train is also known as data preparation. So that's how the modern data warehouse architecture, reference architecture, is structured out. So what we'll be paying attention to in this session is this particular section, which is store and prep and train or data preparation. And also keep in mind that this is actually an outdated modern data warehouse architecture. The updated modern data warehouse architecture is entirely based on Azure Synapse Analytics. So I thought of going with the outdated version because this session is entirely based on Azure Data Factory, and I didn't want you guys to get it confused with Azure Synapse Analytics. So I thought of going with the outdated version just to make things clearer for you guys and to make you understand things better. Right. So now we have a decent background on a modern data warehouse, and it's time for us to look at what data preparation is. So data is extracted from multiple data sources. Data is extracted from multiple data sources and for a modern data warehouse solution, or you can say data is ingested from multiple data sources from a modern data warehouse solution. And all these types of data might not be prepared for analytical purposes, right? So what we need to do is we need to prepare the data for analytical purposes. And in this process, there are two key tasks involved. That's data cleansing and data transformation. So data cleansing is all about cleaning up the data, and data transformation is all about changing the structure of the data to fit in with the analytical needs. And this will gradually improve the data quality and data accuracy. For example, if you take a simple data cleansing task like replacing null values with some kind of a value. So this would gradually improve the data quality and accuracy as well. So there is a definite improvement in data quality and accuracy with data preparation. Right. Now we have an understanding on the modern data warehouse, and we have an understanding on the data preparation in a modern data warehouse. And now it's time for us to look at the feature of this session that we are looking at, which is Power Query in Azure Data Factory. So Azure Data Factory Power Query was previously known as Wrangling Data Flows. When it was initially launched, it was known as it was considered as two types of data flows: mapping data flows, which is another type of a data flow, and wrangling data flows. Then with time, wrangling data flows was renamed to Power Query and was moved into a separate location in Azure Data Factory, but it still is a type of a data flow. The key advantage, the key advantage of this, or the Power Query Azure Data Factory feature, is that it enables code-free or no-code data preparation, which means that you don't need to code for data preparation, and the entire functionality of data preparation is handled with the use of Power Query. In other words, you don't need to know Python, you don't need to know PySpark, or you don't even need to know SQL to do your data preparation. You just need to know the Power Query that you had used previously, maybe in Power BI. So that's all you need to know in order to use the Power Query Azure Data Factory feature. Also, this Power Query that is used in Azure Data Factory is converted into Spark in the backend. So if you don't know what Spark is, just keep in mind that Spark is a unified engine for large-scale data processing, and it facilitates big data workloads. So what happens is that the M language code, or the Power Query code, Power Query in the back, what you see in the front end of the Power Query feature in Azure Data Factory is converted into Spark code in the backend for optimized data processing and for handling big data workloads. So that functionality, that is a process that's happening in the backend of Power Query in Azure Data Factory. Also, as with all the other, majority of the features in Azure Data Factory, Power Query in Azure Data Factory can be executed as a pipeline activity whenever it's required as well, whenever it's required. So you might be knowing of other Azure Data Factory activities, such as very popular Azure Data Factory activities are copy data. Then also you have the mapping data flows, the data flows, Power Query activity, and as similar to all those Power Query as similar to all those Azure Data Factory activities, there is a separate Power activity for Power Query as well. So I'll be showing you around that in the demo. So if you don't understand that, that's completely fine. You will get it during the demo sessions, during the demos I'll be having. Right. So out of all these details, the most important thing to keep in mind is that this feature is still in public preview, which means that you cannot use this feature as of yet for your industrial solutions. I'm doing this session for you to shed some light on you in terms of where you can use this feature, Power Query in Azure Data Factory, in abundant data warehouse solutions, once this feature is out of public preview and generally available. Right. So I hope you got a good understanding of this Power Query feature in Azure Data Factory. And even if you don't, that's completely fine. We'll be having a range of demos in this session. And you will definitely get what Power Query get a taste around this feature, and will be able to use it. You will be able to understand it and use it once this is generally available. And maybe try it when it's try it out when it's publicly available in public preview right now as well. Right. Right. So previously, a few slides back, I walked you through the abundant data warehouse reference architecture, right? So in that reference architecture, if I take your attention to this specific section, which includes the key components, ingest, throw, prep and train, which is data preparation, you can see that as per the default technologies suggested, default technologies suggested, Azure Databricks is recommended as a default technology for data preparation over prep and train. What we'll be doing in this session is we'll be using Power Query Azure Data Factory instead of Azure Databricks in this stage. Let me take you. So in order to understand this way better, so this is just a high level view of in terms of what we'll be doing in this session. And in order to understand this the way better, let me take you to a detailed view of this architecture so that you can understand a view of how this happens or how we use Power Query in Azure Data Factory for data preparation instead of Databricks. Right. Okay. So how we do that is if I take you through the architecture itself, you can see you have 3 stages: ingest, throw, and data preparation, right? So what I'll be doing as a detail, what I'll be showing you is a detailed process of in terms of how this happens with Power Query in Azure Data Factory from data ingestion to data preparation. So let's quickly have a look at that. So firstly, you have multiple data sources, and the data is ingested from multiple data sources with the use of Azure Data Factory, and the ingested data is stored in the row zone in Azure Data Lake. And the data that is stored in the row zone in Azure Data Lake is referred or used as the input data for data preparation, and the data is prepared with this data, and the prepared data will be stored or loaded into the stage zone in Azure Data Lake. So that's how it works. Once again, if I take you through that, you have multiple data sources, and the data is ingested from multiple data sources into the row zone in Azure Data Lake, and from the row zone, the data in the row zone ingested into the row zone will be referred by the Power Query feature in Azure Data Factory for data preparation, and the data preparation will be carried out, and the prepared data will be stored or loaded into the stage zone in Azure Data Lake. So what are these zones in Azure Data Lake or in a data lake? So zones are used to organize data in a data lake. Each zone represents data in a different stage of the data lake of a data lake solution. Right. In this case, we have just two zones, which are row zone and the state zone. And when it comes to real world solutions, there will be more zones coming in, like the user drop zone, you have the curated zone, and so on. So in this case, I have just considered only two zones, which is the row zone and the state zone. Row zone is used to store the data that are ingested as is. Data ingested as is from the respective data sources, and the state zone is used to store the prepared data. So I just went with two zones just to make sure that you guys to make things simpler for you guys simpler for you guys to understand things way better. Right. Now that we have an understanding now we have an understanding in terms of how we should use the Power Query feature in Azure Data Factory. And now it's time to now it's time for us to just try it out in Azure Databricks, right? So the first thing that we should be doing before we use the Power Query feature is creating the dataset. So we have to create two datasets in this stage. One is the input dataset and the other one is the output dataset. So the input dataset, as I showed you in the previous architecture diagram, refers to the Azure Data Lake row zone, while the output dataset refers to the state zone. So from the input dataset, we get the data in for data preparation. We load the data for data preparation, and by the state zone, what we do is after the data preparation tasks are carried out, we load it back for storage into the state zone. Right. So we'll create these two datasets right now, and for that I will be accessing my Azure Data Factory, and you can see that my Azure Data Factory in the screen right now. And how you create the dataset is that you go into you can see the Data Factory resources on your the left hand side of your screen. And also you can see a subsection called data set in here. So what you do is Data Factory resources, data set, click on the ellipsis and click on new data set. Or else you can just click on the plus icon that you see on the right hand side of the search bar in factory resources as well. So that would do as well. So I would just create it that way. So click on the data set and it would start creating a new data set for you. And in the wizard, you should select Azure Data Lake Gen 2 because my source is based on Azure Data Lake Gen 2 because my Azure Data Lake is based on Azure Data Lake Gen 2. And then you should select the file type for your data. And my file type is Parquet. So I would click on Parquet and I would click on continue. And after I click on continue, I'm asked to enter a name for my input dataset. So I would create, I just call this PQ input, and the link service would be Data Lake Gen 2, which is the link service I have right now connected to my data lake that's right here. I would take you through the data lake after I create the data set so that you can understand it better. Right. So that's about it. I would click on OK and move on from here. And that would create my data set. And the next thing I want to do is before writing any logic Power Query, before writing any Azure Data Factory expressions or suggesting a specific folder, I want to add in some parameters, because that's the way how you go about this. You don't specifically specify specific folders, you just handle everything by parameters and minimize the number of data sets, which is the appropriate way to go about things. So I will create two parameters here. One parameter is called table type, will be called table type, and the other parameter would be called file. So I have created two parameters here, and the next thing I want to do is I just want to use some Azure Data Factory expressions just to get this in order to refer these parameters and refer to the respective datasets, right? First thing I'll do is I had written a very simple concatenated Azure Data Factory logic expression to refer to the table type and refer to the row section in my Azure Data Lake. And also I would use another logic, concatenation logic, just to refer to that respective file in the input dataset. Right. So I had created my dataset, and you guys might be confused right now in terms of these expressions and what this all does. So let me just take you through from the beginning for that. So as I told you previously, this is my data lake, and in my data lake I have two zones, which is row zone and the state zone, right? So what I'll be doing is I will my Azure Data Factory or my input data set will be referring to this row zone to get the respective data for data preparation, right? So inside the row zone, you have two types of tables. You have the master tables and also you have the transaction tables. So that's broken down into two separate folders. And inside those folders, it is referred to the respective year, then it's referred to the respective month, and then it's referred to the respective date. That's how I had created the file structure for this particular demo. So according to your solutions, according to the requirements of your solutions, modern data warehouse solutions or data lake solutions, this can vary. So in this case, just to keep things simple for you guys and help you guys understand things way better, I had kept things simple as possible, right? So I have the row zone and the row zone, and inside the row zone I have table types, and inside the table types, master and transaction. So inside the table types, it's referred to year, month, and day. And inside that, I have the respective files, which is referred to by the file parameter. So I hope you guys got an understanding on that in terms of the input data set. So what I'm doing here is I have created table type to capture my master or transaction, table, right? To capture whether it's a master or transaction table, and file to capture the respective file, right? And what I do in this logic, referring to the root folder, is that I refer to the row stage, I refer to the row sort, which is this right here. And what I do is I refer to the respective table type, right? So the table type is master or transaction. And what I do in the next part, Azure Data Factory expression is that I refer to the respective year from this, get it from the UTC now date, and I refer to the respective month as I showed with the structure previously, and I refer to the respective date, and also I refer to the respective file name. So that's how I had structured this. And so let's see how this works from the from Azure Data Factory, whether it captures the right kind of data. So how I do that is, so I want, so first let's figure out which dataset or which file you need to point the dataset for. So firstly, I want to point it out for the, I just want to point it out for now for the master table type, and inside the master table type, I want to point it out for the file territory. So what I'll do is just to check whether this works out, I will click on the browse icon I see on my right hand side, and I'm sorry, that was a mistake. It's not browse. I should click on the preview data option I see on my right hand side. I have to scroll to the right hand side a bit for that. And what I would do is I would enter my respective table type as master, and I would enter my file name as Parquet, and it should work out. Let's see how it goes. Right, so it doesn't seem to work out. So let me just look at why that is happening. Row P Q U E. Let Q U E T. I was just checking whether I spell Parquet right. Territory. Yes, that is fine. Master territory path is missing. Right, so it's 2021-99 master, and the path is missing, which is a bit weird. So let me just refer to the respective folder path and see how that works. So right now I'm just getting an error saying the path is missing. And let me just, okay, start 2021. So I don't specifically see anything wrong here. So it's 2021-99 row master 2021-99 territory path. Right, so seems like we have an issue here, and I don't want to waste my time to waste your time to fix this right now. But it's pretty weird. Let me just have a look at it again. Okay, master territory packet, and okay, I think I just is it because no, not really. So it's capturing the date, right, as you can see, but for some reason it's not being referred to the right right territory packet. to the right file. So let me just try something else also. So I would, maybe I just typed it wrong maybe. So I would right. Okay, so still we have an issue here. So I would just leave this as it is for now, but ideally this dataset cannot be used for Power Query as well. So there's something wrong here that doesn't seem to work right. So I would leave this right here for now. And if we have time, maybe let's come back. But we have the data set up properly with the respective data factory expressions, and let's set up the output data set real quick. So the output data set is the same, and we'll be referring it to this state zone. So the state zone is right here, and I would, once again, there are file types for that. You have to select between master and transaction once again, and inside that you have the respective folders for the respective entities, or you can say the respective data, customer and territory in this case. And inside that you have the file structure set up to year, month, day, and it goes on to the file. So the structure here is a bit different from the row. So in the row, we just refer to stay from row to the file type, master transaction, and from that we had year, month, and afterwards day, and then you had your respective files. But here it's a bit different. Here we had gone from the state zone to the file type, master or transaction, and from there we had divided, organized into separate folders as customer, and we had organized as master tables and transaction tables by their name accordingly into separate folders, and inside those folders we have the structure that's followed: year, month, day, and then you have the respective file. So that's how it's been done. So let's quickly do it to here as well. So it's Azure Data Lake Gen 2. And I would go with Parquet and click on continue, and I would call this PQ output, and click on OK. And after clicking on OK, I would just move on from here and click. I would simply move out of here, and what I would do next is I would be referring. I would be putting in some logic once again, just to refer to the respective output dataset. So for that, I would go into the folder. I would go into the file path in the respective created dataset, and I would just paste this logic. So it's just this is once again, this does not have parameters, because parameters are not actually allowed, or not something that's applicable with the Power Query Azure Data Factory. So even though what I was supposed to do in here is that to show you that to draw create the Power Query input dataset with Azure Data Factory expressions, and just to with parameters and Azure Data Factory expressions, and show you guys that it's not working. So the parameters actually works out, right? Parameters works, sorry. So parameters are working, but Azure Data Factory expressions are not working for input datasets. So that's why what I wanted to show you here. But the output dataset is fine. You can run in parameters and do it. So rather than doing it this way, you can also have the parameters set up to a table type and the table name, and you can minimize the number of datasets. But in this case, I'll not be doing that. I'll be referring to a very specific folder, which is called the territory table name folder, territory table folder, and I would be getting in the data accordingly based on the UTC now divided into year, month, and day. So that's how I'll be going about this. So I hope you got an understanding on the data sets. So next thing what we should be doing is we should be creating Power Query. How we create Power Query is creating the Power Query, which is using the Azure Data Factory Power Query feature. So how you do that is, so we have the input and the output datasets, so we are fine. So once again, as with the datasets, you can create it with the plus icon you see on right next to the search bar in the factory resources, or you can create it, with the Power Query option, with the Power Query subsection that you see under factory resources, and you can go into new Power Query and create it. So in this case, I just use new Power Query this way and create my Power Query, and they ask for the source dataset, which is the input dataset right here. So you can see that if I just give PQ input here, it would not be capturing because let me just expand it a bit for you. PQ input. So you can see PQ input does not work out here because dataset without a schema is not allowed, and also Azure Data Factory expressions are not allowed for input datasets as well. So you all know that if you are going with parameters, and you all might be knowing that if you are going with parameters and if you are using Azure Data Factory expressions, you can't really specify a schema, right? You can't specifically do that because you will be referring the same data set for multiple stages, right? For multiple purposes with the use of parameters. So defining a hard and fast schema is not really applicable. So basically, in other words, data sets with Azure Data Factory expressions are input datasets with Azure Data Factory expressions are not really applicable with the use of Power Query and Azure Data Factory yet. So probably before it comes out of general, before it becomes generally available, this feature will be taken into account and provided a solution with accordingly, as this is something essential when it comes to any kind of development in Azure Data Factory. So it is a good practice to use parameters for and minimize the number of Azure Data Factory components or the resources that you have with the use of parameters, right? So it does not. So what I can say with this kind of problem that I see here is that it does not cater that best practice as of yet, but definitely before it comes out, before it becomes generally available, this feature would be fixed. So because of that, what I'll be doing is I would be using a fixed data set for this. Fixed data set in the sense a data set that does not use any Power Query expressions and refers exactly to the respective file, to the respective folder in the respective file. This is definitely not the right way to go in industrial solutions, but since the Power Query feature does not allow data factory expressions, what I'll be doing is I'll be using a fixed data set to show you guys around for now. But once it's definitely once it's generally available, you should not be and should not use fixed data sets like this even to try out. You should always go with the parameters and do it with the best practices much as possible. Right. Keeping that in mind, I will be referring to a fixed data set. So the fixed data set I'll be referring to is PQ territory. So I would click on PQ territory. I would search for PQ territory and it would capture my data set. And the next thing I will do is I want to click on. All right. So as you can see, you should be able to see the Power Query loaded right now. I'm sorry, the data set loaded right now for territory in my respective in my window. So you can see that the Power Query is loaded and nothing much really to show here, but it's same as with Power BI. If you guys had worked with Power BI before, you have the same Power Query features, but just to a few things, I'll take you to a few things to keep in mind. So you have something called under queries in the left-hand side of your screen. So you can see that this is exactly the Power Query view you see in Power BI as well, right? So I will not be going through each and everything, but I will be picking out some differences that I see in here, and I would be picking out certain different things that I see in here compared to Power BI, and I would be showing you around that. So one difference that I see with comparison to Power BI is this ADF resource folder under queries. There is no ADF resource folder as such under that is generated automatically in Power BI as that. So what this refers to the respective source datasets that are referred, and user query is basically the query that's used to prepare the data and to load the data into the stage zone. So this just refers to the input data set or to the row zone and refers to the respective data set. And the user query is about the prepared data that will be loaded into the stage zone. And few more differences to keep note of. Under Home tab, under Home, you can see options called project option. You can see option called options, and inside that you can see two types of options: project options and global options. Global options are the default options for any project that you do with Azure Data Factory. So it has certain default settings like default editor view, editor step analysis, and so on. You guys can have a look at this. You can do even column profiling as with Power BI. You can decide whether you want to say show the entire data set or just 1,000 rows as with Power BI as well. And type detection, which is what I had set for is detect column types and headers for unstructured sources according to each project setting. Then there is something called details and you can enable, and as with Power BI, you can use display preview contents where using monospace font. So there are multiple options. And there is always allow parameterization in data source and transformation dialog. So there are multiple options like that, which are global options to any project that you do with Azure Data Factory. Then there are project-specific options as well. Some of them allow combining data from multiple sources and just an export diagnosis for any performance related issues or stuff like that. So that's just some of the options that you see here. And also with comparison to Power BI, there are some differences in terms of the view, in terms of the views in Power Query. So in Power BI, you might know it, the Power Query view just has this tabular view, but when it comes to Azure Data Factory Power Query, you have something called a diagram view, which just shows you kind of like a route map. Is that what you say? It's like a map visual that shows you which sources that the particular query is referred to, a kind of thing. And you can just hit down, click on that, and just see further details on that. And that's the what do you call the diagram view. And then you have the tabular data view, which is similar to the Power BI view as usual. I'm just clicking on the data view and just deselecting the diagram view. And there is something called also the schema view, which just shows you the schema related details related to the respective data sets. So those are just some kind of views that are some things that are different, and you can see everything else is like very similar to the Power Query view in Power BI. On the right hand side, you can see the query settings, and in the left hand side, you can see the queries, and you have the tabs home, transform, add column as with Power BI with all the Power Query functionalities that you can use for data preparation. So all that is right there. And yeah, so all that is right there without any complications. So hope you guys had a good understanding of the Power Query interface and what you can do around that and the options that are available. So how you create a Power Query is very easy. So we had already created a Power Query itself with the options process that we followed. So the next thing I want to show you is, so that is how we create a Power Query. And the next thing I want to show you is how to configure, use the Power Query we created and configure a pipeline activity. Let's quickly have a look at that. So how we do that is you head down to a pipeline, or let's create a new pipeline in this state. So I will create a new pipeline. So how you create a new pipeline is under factory resources, under the subsection pipeline, you should be able to see an option called new pipeline after you click on the ellipsis. So you can create it from there, or as I told you before, with the plus icon you see on the right hand side, you can create a pipeline as well. So I would just click on that and create a new pipeline. And I had created a pipeline called pipeline 1. I'll just leave it with the default name as it is. So what I'll be doing next is I would be referring to the configuring the Power Query activity, pipeline Power Query activity, in order to execute the pipeline and execute the Power Query for data preparation. So for that, I would just search for, just when you type Power, you should see an option called Power Query, the activity called Power Query popping up. So just drag and drop it into the workspace. And after dragging and dropping that, you can see, as with all the other options, Power Query activities, you can see that you have the settings right here. You have the general settings, which is similar to most of the other data factory expressions, data factory activities. And then we have something called settings, which is where you have to select the respective Power Query. So in this case, the name of my Power Query is Power Query 2. So I would just search for Power Query 2, and you can see Power Query 2 is right here. So I would click on that, and you can decide the integration runtime. So In this case, everything is on Azure. It would be auto-resolve integration runtime. And then you can select the compute type. You have three types of compute types, which is general purpose, memory optimized, and compute optimized. So memory optimized is all about giving your execution more RAM, and compute optimized is all about giving your execution more CPU. So general purpose is basically for general purposes like this case. So based on the fact whether you want to do it, you want to just go about it casually, like for research and development, or whether you want to give it more RAM or more CPU, you can select your compute type accordingly and work on it accordingly. And also there is something called core count, which decides the number of cores that you can give. So as far as I remember, you can go up to 256. You can go up to 256 cores and just increase your increase the performance of your execution. But for R&D purposes, I recommend you to at least stick with around 4, 8, and 16, since R&D datasets and everything are quite small, and there is no necessity for you to go to a large number of cores. So large number of cores are ideally related for big data situations, and when you have lots and lots of data that that would get several hours for you to execute if you are executing with minimal number of cores. So that's just some understanding for you. So in this case, I would just keep it as the default 4 cores. So that's about it. And then after that, you have to select the sync dataset in here. So my sync dataset would be the PQ output dataset, which I created in the previous demo. And you have the usual options, like whether you want to clear the folder when you are like doing the execution, or whether you want to validate the schema, allow schema drift, and whether you want to output to a single file. So in this case, I would select an output to a single file, and I would call this file territory.py. Okay. Right. So yeah, this all depends on like how you want to go about this and how you want to provide your solution with. So there is no strict and hard and fast rule for one data warehouse solutions or data lake solutions. It entirely depends on the solution that you should provide to your client, and like how you will be handling that solution and kind of thing. So it's that kind of a thing. And then you have the mapping. So I would go with the auto mapping at this stage. So that's about it. So I had configured the Power Query pipeline activity inside the new pipeline, as you can see in the screen right now. So I would not be executing this. In this, the execution might get a bit of time and it can be a bit annoying. Yeah, so then I think, so that's how you configure a pipeline activity. So you might know that I didn't do any data preparation tasks when I was in the Power Query way, because I am in the assumption that most of you guys use Power BI, and most of you guys know how to do this Power Query data preparation stuff tasks easily. So I didn't go through that. I just wanted to pay attention to the most important core sections of the Power Query feature in Azure Data Factory, because I think most of you guys know how to use Power Query and had worked with it. So doing transformations, I felt that I should pay more attention to other kind of stuff that are new for you guys rather than the Power Query that you guys already know. But I had just set up a demo just to showcase some scenarios, some very simple scenarios with Power Query data preparation I had done not in Azure Data Factory. So let me quickly take you through that section. The first thing I want to show you is PQ territory. So PQ territory, as you can remember, we referred to in the demo process too, but we did not do any transformations. We just referred into the input data set, referred into the output data set, configured the pipeline activity, and just showed you around the Power Query feature in Azure Data Factory. So that's was my main purpose of that. So I didn't do any Power Query transformations here, as you can see on the query settings in the right-hand side of the screen. So I have a version that I had already created with some transformation. So in this case, I had just removed the columns, unwanted columns, and I had created the Power Query in here. So if I go to a bit of complex one, a bit complex Power Query. So this is PQ territory, which is what we use to the demo that you just saw. We have PQ custom. So as you can see, it's a bit complex. So it's referring to two input data sets, as you can see, PQ customer and PQ person. And what it does is it refers to PQ customer first, and after that it merges with PQ person to get specific attributes. And the attributes from PQ person are expanded afterwards. And after expanding that, the unwanted columns are removed. So that's all about the Power Query that I had provided there. So you can see it much more clearly. I don't even think that I should take you through these Power Query steps, because I think you guys are very well aware of this. So that's how it happened, and it had happened. Then if I take you into a transactional Power Query, which is Power Query cells, Power Query that I wrote, a bit complicated than PQ customer, which is master Power Query, which is a master table Power Query, but a bit complicated than that, but still not overly complicated, decent enough for you to understand. So once again, it refers to two input data sets, Power Query order header and Power Query order detail, and it is referred by user query, as I told, for all the data preparation tasks I handle in user query. You can see the user query is available right here. So now what happens is, firstly, Power Query header is referred and it's merged with Power Query order detail, and basically a join that you do with Power order header and order detail, like you do in the real world scenario. So, but it's a lot more simpler than that. You do that, and after that, what you do is you expand the necessary columns from Power Query order detail after merging, and then you remove the unwanted columns. Then you order the columns into an organized way. Then you replace certain values, basically null values, into -1s at certain stages that's required. Maybe I think it's for keys, some keys. It's for currency rate ID, which was absolutely shown as null. Just convert it most of the time. Just converted it to -1 just to add more addition for this data preparation task. And then I rename some columns. Yeah, that's about it. So I have my sales Power Query ready with that. So those are just some of the scenarios that I had worked with, and that concludes my session. And I hope you guys got something out of this session in terms of the Power Query feature in Azure Data Factory, and hope you guys got something out of this session to go and try things out in terms of Azure Power Query in Azure Data Factory. And hope and thank you very much for attending my session, and thank you very much for the organizers for having me. It's great to be here, and it's definitely a privilege to be here. And also, please use the QR code to provide me feedback as well. I just want to improve myself further as a speaker and provide a better contribution to this community. So please be kind enough to just scan the QR code and provide the feedback, or else you can use the evaluation feedback form as well and provide me some feedback, so I'll get it and I can improve myself further. So hope you guys got something out of this session, something important out of this session that you guys can try out with Azure Data Factory and probably achieve something great when this Power Query Azure Data Factory feature is generally available. Yeah, thank you very much.
Yeah, it was a really great session, Tamanta, and we have one question come here, and which is from Piyush. So he's asking, is there a quick way, code-free way to convert the CSV file to Parquet? Is it any option for that? To convert the CSV to Parquet using the using Codelet's solution?
Yes, there are two ways, right? One way is just 2 lines of code, and the other way is with the use of Azure Data Factory, which I can think of right now. First way to do it is with Azure Data Factory. How you can do it is use copy data activity in Azure Data Factory and use your source dataset as that respective CSV dataset. And for the destination dataset, make sure that you define a Parquet dataset. And all you need to do is to run that copy data activity with the run that pipeline with the copy data activity, and you will have a Parquet file converted. A CS file that's converted to a Parquet file. So if that's too much of work, you can also use something like a Python notebook, right? And use some you can use the pandas code, the pandas Python package, and just do a read CSV and just save it as convert it to a what you call Parquet and just download the Parquet. So that's possible as well. So those are the two solutions that I can think of. But if you want to convert it with Azure Data Factory, so the first option is the best way to go. But the second option is definitely possible as well. So yeah, those are the two options that I can think of right now. Yeah.
Hi Piyush, I think Tamanta has actually answered your question, right? Yeah. So we have sorry, we have one more query from Jay, right? Some Jay.
All right.
So yeah, so he's asking that if I missed it, he mentioned that with the auto translation of M to Spark, is there any possible way to create a view or edit in the Scala translation directly? Any way we can do it?
Not really, not as per now. This feature, remember, this feature is still in public preview, so it might be enabled in the future. But as per now, all the translations, all the conversions from the Power Query M language to the Spark code is done in the backend. So that's not really exposed. That's something Azure Data Factory does in the backend and provides us the output. Yeah.
Okay, I mean, thanks. He has actually said thanks to you.
Thank
you.
So
guys, if you have any other query, you can just, we have just 1 minute left. I mean, actually you overshot, but we still have some, anyone have some other query? Tamanta can still ask you. We have given 1 minute
definitely.
to you. Yeah. So Piyush, Jay, anyone from that matter, anyone who wants to have any query about Azure Data Factory or anything? So Tamanta, this is from from me myself, right? Now I have learned a lot of things from PO and other things. So people who are just learning the Azure Data Factory, can you give some guidance about how they can just learn and then they can just make their own data factory and how they can just test it out, and any guidance you can give? I mean, people are just beginner.
Right, definitely. So beginners, so I would thoroughly recommend the Microsoft Learning resources. So you can go navigate yourself into go to Microsoft Learning, and in that you have a lot of Azure Data Factory resources and really nice learning paths for you to start from the very scratch and to advance yourself step by step accordingly. And also, but that's the number one resource for me as per my knowledge. If you want, I can just find some resources for you guys and give that as well. So it's not like really difficult, but I would recommend that with Azure Data Factory, also pay attention to Azure Synapse pipelines, which is like same as Azure Data Factory, but as an individual who is as a freshman, it's always good to keep an eye on both these technologies, since Azure Synapse would be ideally the future in data, not only in data engineering, but in most of the data analytics related tasks. So that's something to keep in mind. So all those resources are available in Microsoft Learning for you guys. You guys can start from scratch and work on it. And if required, if there is any opportunity, I can even do beginner sessions for you guys to catch up and to upgrade your careers. Yeah, thank you. I hope I provided.
Yes, yeah. It's very beneficial. So I'll be sending the links to the audience soon on that. And again, really great session, Tamanda. It's really something which everyone learned from you. And although it's a bit complex, I mean, like doing the things, but although it's a no code, but something a lot of people just learned from you. And we really thank you for your time. And we say good night to everyone. It's quite late in Singapore. It's quite late, and maybe Sri Lanka now as well. So we say good night and be safe.
Right. Thank you, Aro. Thank you, Pio, and thank you, Asif, for this opportunity. Yeah, hope you guys had a great time in my session, and hope you guys got something out of it. So good night to everyone. Thank you.
Sure. Thanks, everyone, and be safe. Bye-bye.